Chapter 3.3, Writing Algebraic Expressions. So today we're going to be talking about using word phrases to write an algebraic expression or use an algebraic expression to write a word phrase. So here we have four operations. We have our addition, subtraction, multiplication, and division. These word phrases are different ways to say or indicate what operation you are doing. So a number m plus 45, obviously you're adding. The sum, remember sum is the answer to a multiplication or addition problem. Sorry, not multiplication, addition, sum, addition. Okay, 45 more than a number m. I want you to notice all three of these are using the phrase a number and the variable m. A number x, a number t, a number r. I don't care what variable you use, but I want you to use the phrase a number in front of that variable to indicate that that variable is in fact a number and not a letter. Okay? So, subtraction. A number p minus 6. The difference. Difference tells you to subtract. The difference of a number p and 6. 6 subtracted from a number p. All of these mean p minus 6. 4 times a number k. The product tells you to multiply, of 4 and a number k. Notice, 4k. I now want you to write it like this, as the number, it's called a coefficient, and then k, your variable. Sometimes you guys write them as 4 times k or 4 times k. Both of these mean this, 4k. Okay? This is the more sophisticated way to write it, so I want you to try and get into the habit of writing your multiplication like this. Okay? Now, division can sometimes seem a little tricky at first. Quotient tells you to divide. So the quotient of a number z and 25. In division, the first number in the statement or variable is always your dividend. So it is this number or it is the numerator if it looks like division. The second number is your divisor. It's the second number, your divisor, or it's the denominator. Okay? So they go in order. Dividend, divisor, numerator, denominator. A number z divided by 25, you can write it either way. Z divided by 25 or z over 25. These two mean the same thing. Okay? All right, let's take a look at example 1. And write an expression for the product of 7 and k. Product tells me to multiply. So that means 7 times k, which we're going to write in the sophisticated way of 7k. That's it. You need to make sure that you pay attention to those key words, product, sum, difference, quotient, because that will tell you what operation you're supposed to use. Okay, example 2. You go bowling and bowl 3 games. Shoe rental for the 3 days, or for the day, was $1.75. Write an algebraic expression for the total amount of money that you pay. So I'm going to use my good friend, the bar model. You don't have to, but I want to visualize what it is that I am doing. So, I'm just going to change colors though. We'll use purple. So, I have the total amount of money that I paid to go bowling. It's my total. I don't know what my total was. It is my unknown. So I'm going to call it x. Okay? So to start my algebraic equation, I'm going to say x equals, x is my total. I'm not sure. I know that I bowled 3 games, and I know that my shoe rental was $1.75. So here are my shoes. They cost me $1.75. The rest of my total was spent evenly on those 3 games. Game 1, Game 2, and Game 3. Each of these 3 games is the same price. So I'm actually going to change my variable. I'm going to move it. This is just going to equal my total. I'll move this too. Pen, come back. My total is going to equal the cost of my 3 games plus $1.75. I don't know how much I paid for each game, do I? I go bowling and bowl 3 games. I'm not sure what I paid, so I'm going to call that my X. I paid X dollars for 1 game. I paid X dollars for the 2nd game and X dollars for the 3rd game. It's all the same. So I have 1, 2, 3 X's. 1 here, 2, and 3. So my algebraic expression is 3x plus $1.75. That will tell me the total amount of money I paid to go bowling. Now, if you look in your book, you'll see that they used the variable g for game. Doesn't matter what variable you use. You can use any letter you want to. I will only caution you that if you use the letter T, it needs to have that little hook on the bottom because a T and a plus sign can look exactly the same. All right, last one, example 3. You can see a relationship between numbers when they are organized in a table. You can use an algebraic expression to describe that relationship. So this one is actually multiple choice. The table at the left shows the length of the sides of 3 squares. This is the table right here. If the side of my table was 2 centimeters, my perimeter is 8 centimeters because I'm going to add them all up. It's a square. If it is 3, 12 centimeters. 5, 20 centimeters. Okay, the perimeter of a square equals 4 times s, 4 times the side length. So, which expression can you use to find the perimeter? We just did it. If my side length is 2, I multiplied that by 4 because there are 4 sides in a square. 4 times 2 is 8. So, 4 is my constant. I see that each and every time. Times s, the side length, will equal the perimeter. Perimeter. So 4s, or 4 times s, is your algebraic expression for that table. Some of them will be multiplication, some division, some addition, some subtraction. That's it. Do your QCs and CYUs, and I will see you later.